When assisting with residential wiring, understanding the National Electrical Code, or NEC, requirements for branch circuits and taps is crucial. You mentioned using 20-amp breakers and 12-2 with ground wire for home runs and mainline runs, and the question is whether you can tap off that main run to switches and other low-use items like ceiling fans and lights using the same 12-2 with ground wire. The NEC does allow for smaller conductors to be used for branch circuits that serve lighting and other low-use loads. Understanding specific requirements is key. Regarding branch circuit requirements, the maximum allowable load for a 20-amp circuit is 80% of the breaker rating, which equals 16 amps. NEC Table 402.5 addresses conductor ampacities and applications. Lighting loads and other low-use loads typically draw less than 16 amps, making it acceptable to use 12-2 with ground wire for these circuits under normal conditions. Considering taps off the mainline run, when tapping off a 20-amp mainline run, the tap conductors must also be rated for at least 20 amps according to common interpretations of best practices, but must be able to handle the load placed upon it. This generally means that 12-2 with ground wire should be used for all taps, even if the branch circuit only serves lighting or other low-use loads. The tap should be made using appropriate wiring methods such as solderless connectors, wire nuts, or terminal blocks, ensuring secure and code-compliant connections. Firstly, conductor size and ampacity are key considerations. The NEC specifies ampacity requirements for conductors based on their size and insulation type. 12-2 with ground wire typically has an ampacity of 20 amps, which is suitable for a 20-amp circuit. Secondly, overcurrent protection is vital. Branch circuits must be protected by overcurrent devices, such as circuit breakers or fuses, sized appropriately for the conductor ampacity. A 20-amp circuit should have a 20-amp breaker to protect the wiring from overloads and short circuits. Thirdly, load calculations are important. Before installing any wiring, calculate the expected load on each circuit. This includes lighting, receptacles, and any other electrical equipment that will be connected to the circuit. Ensure that the total load does not exceed 80% of the circuit's capacity. Fourthly, wiring methods must adhere to standards. Use appropriate wiring methods for the installation, such as non-metallic sheath cable NMB for dry locations or conduit for wet or hazardous locations. Securely fasten the wiring to studs or joists using appropriate staples or clamps. Fifthly, grounding and bonding are required for safety. Ground all metal enclosures and equipment to provide a path for fault current to return to the source, reducing the risk of electric shock. Bond all non-current carrying metal parts together to create a low impedance ground path. Sixthly, junction boxes are important for connections. Use junction boxes for all wire splices and connections. Ensure that the junction boxes are accessible and properly covered. Seventhly, labeling is necessary for clarity. Label each circuit breaker and junction box to indicate the areas or equipment they serve. This helps with troubleshooting and maintenance in the future. Eighthly, local codes must be followed. Always check with your local building inspector or electrical code to ensure compliance with all applicable regulations. Local codes may have additional requirements or restrictions beyond the NEC. Ninthly, professional consultation is advised. If you are unsure about any aspect of the electrical work, consult with a licensed electrician. They can provide guidance and ensure that the installation is safe and code compliant. Tenthly, documentation is valuable. Keep a record of all electrical work performed, including wiring diagrams and load calculations. This documentation can be helpful for future maintenance or modifications. Additional best practices for electrical wiring include ensuring proper wire connections. Use wire connectors that are rated for the size and type of wire being used. Twist the wires together tightly before applying the connector to ensure a secure connection. Avoid overstripping the wires, as this can expose too much bare conductor and increase the risk of short circuits. Another point is to avoid overloading circuits. Distribute the electrical load evenly across multiple circuits to prevent overloading any one circuit. Consider using dedicated circuits for high-power appliances, such as refrigerators, air conditioners, and electric ranges. Always use the correct size and type of wire for the application. Refer to the NEC tables to determine the appropriate wire size for the circuit's ampacity and voltage drop requirements. Using undersized wire can cause overheating and potentially lead to a fire. Another key aspect is to protect wiring from damage. Protect wiring from physical damage by routing it through conduit or using cable guards in areas where it may be exposed to impact or abrasion. Avoid running wiring through areas where it may be exposed to moisture or chemicals. Another safety precaution is to use ground fault circuit interrupters, or GFCIs, in wet locations. Install GFCIs in bathrooms, kitchens, and outdoor areas to protect against electric shock. GFCIs detect ground faults and quickly shut off the power to the circuit. Also, inspect wiring regularly. Periodically inspect your electrical wiring for signs of damage such as frayed insulation, loose connections, or corrosion. Repair any damage promptly to prevent electrical hazards. Always disconnect power before working on electrical circuits. Turn off the circuit breaker or remove the fuse that supplies power to the circuit before working on it. This will prevent electric shock. Use insulated tools when working on electrical circuits. Insulated tools provide an extra layer of protection against electric shock. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. Further, ensure proper grounding. Ensure that all electrical equipment is properly grounded to provide a path for fault current to return to the source. This will help to prevent electric shock. Also, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical equipment. This will help to ensure that the equipment is installed correctly and safely. It's also important to maintain a safe working environment. Keep your work area clean and free of clutter. Use proper lighting to ensure that you can see what you are doing. Wear appropriate personal protective equipment such as safety glasses and gloves. Also, know your limits. If you are not comfortable working on electrical circuits, do not attempt to do so. Hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to take precautions to protect yourself and others. By following these best practices, you can help to ensure that your electrical wiring is safe and code compliant. Some specific NEC articles that may be relevant to your question include Article 210, which covers branch circuits. This article provides requirements for the number of circuits, the types of loads that can be connected to each circuit, and the overcurrent protection requirements. Article 220 covers load calculations. This article provides methods for calculating the electrical load on a building or structure. These calculations are used to determine the size of the service entrance conductors and the number of branch circuits required. Article 240 covers overcurrent protection. This article provides requirements for the selection and installation of overcurrent protective devices, such as circuit breakers and fuses. Article 250 covers grounding and bonding. This article provides requirements for grounding and bonding electrical systems to ensure that they are safe and effective. Article 300 covers wiring methods. This article provides requirements for the installation of electrical wiring, including the types of wiring methods that are permitted, the supports required, and the clearances from other objects. Article 310 covers conductors for general wiring. This article provides requirements for the selection and installation of conductors for general wiring, including the ampacity of conductors, the insulation requirements, and the directing factors that must be applied when conductors are installed in certain conditions. Article 400 covers flexible cords and cables. This article provides requirements for the use of flexible cords and cables, including the types of cords and cables that are permitted, the ampacity of the cords and cables, and the grounding requirements. Article 402 covers fixture wires. This article provides requirements for the use of fixture wires, including the types of fixture wires that are permitted, the ampacity of the fixture wires, and the grounding requirement. Article 404 covers switches. This article provides requirements for the installation of switches, including the type of switches that are permitted, the mounting height, and the wiring requirements. Article 410 covers luminaires, lamp holders, and lamps. This article provides requirements for the installation of luminaires, lamp holders, and lamps, including the type of luminaires that are permitted, the mounting height, and the wiring requirements. Article 422 covers appliances. This article provides requirements for the installation of appliances, including the type of appliances that are permitted, the mounting height, and the wiring requirements. Article 430 covers motors, motor circuits, and controllers. This article provides requirements for the installation of motors, motor circuits, and controllers, including the type of motors that are permitted, the overcurrent protection requirements, and the grounding requirements. Article 440 covers air conditioning and refrigerating equipment. This article provides requirements for the installation of air conditioning and refrigerating equipment, including the type of equipment that is permitted, the overcurrent protection requirements, and the grounding requirements. It's important to consult the latest edition of the NEC and any applicable local codes to ensure compliance with all requirements. Always consult with a licensed electrician if you have any questions about electrical wiring.